Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in mathematics ranging from algebra on up, please consider subscribing to our channel, checking out our videos, playlists, like, share, comment, all those types of things give us a boost in the YouTube algorithm, so please feel free to do those things. We would greatly appreciate it. Let's get into the current video. What is the value of 0.9 repeating? In other words, remember the notation with this bar over top means that this number is repeated. So 0.99999. Now, there are people out there that say, well, okay, so 0.9 clearly is less than 1. Okay, no problem there. 0.99 less than 1. Certainly. 0.999 less than 1. Again, no problem there. Well, there are people that believe that if I was to take the value 0.999 and I do that infinitely many times, this is still less than 1. Again, this is the claim that, well, it has to be just slightly, just a tiny, tiny bit less than 1. How much? They don't know. They just think that it's just a smidgen less, right? Well, let's take a look. Consider the following sequence. A1 is 0.9. A2, 0.99. A3, 0.999. And in general, AN is going to be 0.99 where I have n nines. Okay. Now, if I look at that sequence, every single one of these values is less than 1. Less than 1, less than 1, less than 1, less than 1. So every single one of those is less than 1, and they are all increasing. So there's a famous theorem in mathematics called the monotone convergence theorem that says that if I have a sequence that is monotone, in other words, it is strictly increasing or strictly decreasing, or it could be non-decreasing, non-increasing. But if I have it, let's say it's increasing and it's bounded, then it is convergent. No question. It converges to a real number by the monotone convergence theorem. So by the monotone convergence theorem, the limit as n goes to infinity of an exists. And let's see what it's equal to. Okay, so let's go over to here. Since it exists, I can say that it's equal to some unknown real number. Okay, so I know that it is equal to a fixed real number by the monotone convergence theorem. Therefore, I'm justified in saying 0.9 repeating is equal to some number, let's call it alpha. Okay. Well, let's explore that. Alpha is 0.9999, etc. Now, the way decimals work is I can take the first element of the first component of that decimal, 0.9, and then I can add 0.09 plus 0.009 plus etc. Okay. Again, this is a convergent infinite series. Therefore, we can separate this into the infinite sum. And, well, how about 0.9? That's the same thing as 9 over 10. 0.09 is the same thing as 9 over 100. 0.009 is the same thing as 9 over 1,000, etc. Well, what's the pattern? The denominator is 10, 10 squared, 10 cubed. Okay, so that gives me 9 over 10 plus 9 over 10 squared plus 9 over 10 cubed, etc. Well, this then is an infinite series. The sum from n equals 1 to infinity of 9 over 10 to the n, okay? And what can I do with that? Well, the constant 9 I can pull out front, giving me this is the sum from n equals 1 to infinity of 9 times 1 over 10 to the n is the same thing as 1/10 to the n. And that might look familiar to you. This is a geometric series. And remember the geometric series, we usually have this as the sum from n equals 0 to infinity of a r to the n. So what I can do is I can pull off one of the terms, giving me the sum from n equals 1 to infinity of 9/10 to the 1/10 to the n minus 1. And then what I can do is I can take the initial index and I can decrease it by 1, which means I'm going to increase the index variable by 1, giving me the sum from n equals 0 to infinity of 9/10 times 1/10 to the n. This is a geometric series, and there's a well-known formula for the value of a convergent geometric series. Notice that the value of r in this case is 1/10, whose absolute value is less than 1. Again, therefore, it converges. This is equal to the value of a, so the coefficient, 9/10, divided by 1 minus the value of r, so 1 minus 1/10. Okay, 9/10 divided by, well, 1 minus 1/10, 1 would be 10/10, minus 1/10 would give me 9/10. And of course, this is then equal to 1. So therefore, the value of 0.9 repeating infinitely many times is not a tiny bit less than 1. It is exactly 1. Is that counterintuitive? Perhaps. But anything, I always tell students that whenever infinity gets involved, you kind of have to throw your intuition out the window. Infinity kind of has some bizarre properties. Notice I'm having an infinite sum here, and that can kind of lead to some counterintuitive results that we will explore much more in your Calc 2 class when we talk about sequences and series. Series kind of in your Calc sequence is probably the main place where you're going to see some weird things. So I always tell people just play by the rules and don't let your intuition get in the way. Okay. Anyway, thanks for watching. Please subscribe.